Section 6.3, Math 110. Now, we introduce in these sections 3 equations and 3 variables. We have solved 2 equations and 2 variables, and we study method of substitution and eliminations. But here you have 3 equations and 3 variables. In case of 3 equations and 3 variables, instead of just x and y, you have x, y, and z. And you could actually see that, like in this case, if there are 3 planes or 3 equations, the intersection would be a point. This point has x, y, and z. Or intersections or solution can be a straight line, like in this case is a vertical line. Or solution, if all three equations are the same, then they all overlaps and just one plane is the solutions. And this is a case that there is no solution. So here, like this point is point of intersection of 2 lines, but not 3. Like this point is intersection of these 2 planes. So there is no solution. If you have 3 equations and 3 variables, all 3 planes must intersect at one point. Or in case of the parallel lines or parallel planes, you see there is no intersections. Anyway, so there are basically good way to do it is method of eliminations. In this example, there are 3 variables, x, y, and z, but you already have the z. All I need to do is take the z and substitute here to find the second variable, which is x. So now you have the x, and you could just take it and substitute and the z into the third one to find the z value. So as you see, the point of intersection has x, y, and z instead of just x and y. And here they show you how to do it, interchange, multiply. It's very similar to, it's basically a method of elimination. So what you use to solve 2 equations and 2 variable and 2 equation, you could actually use the same thing for this method. So here it just shows you the solution of these 2, which we use method of eliminations, right? And this is examples of page 445. Now, this is a one that has, they call it Gaussian eliminations. What you do is you have 3 equations. We number them. Equation number 1, equation number 2, equation number 3. Then you try to eliminate one variable between 2 equations. So what we do, we take equation 1 and 2. It's arbitrary selections. I'll take equation 1 and 2, and between these 2, I eliminate x because both are equal and opposite. So I have one equation with just y and z. Okay. Now I'll go ahead and take these 2 equations, equation 1 and equation 3, and try to eliminate x between these 2 equations right here. This is equation 1 and equation 3. So I eliminate x between these 2. Then I find another equation with y and z. So now you have 2 equations. They both have y and z. They don't have any x. So now you take these 2 together and solve it for z and then y. So when you find your z and y here, you have 2 out of 3 variables. You take these 2 and you substitute in one of these three equations. It doesn't matter which one to find your z, but obviously this one is easier to use. So you put your variables here to find the last one. In that case, the final would be 1, -1, and 2. So again, one way of method of elimination here, that you number each equations and then you take a pair each time and eliminate the same variables. It's very similar to that. So if we go back to here, they just ask you to verify whether each pair is a solution. Anytime you want to verify, you want to make sure that the point given in the problem satisfy all three equations. Okay, so that's what I did here. I substitute that into the first one, the second one, and the third one here. So the point given in the problems, you got to take that and substitute in all three equations. If that satisfies all three equations, means if work for all three, then that is the solution of a system. Okay, so here, there's another one. The top. And then this one, they ask you to solve. This is very similar to the example number 1. The z is already given, so you put that here to find the y, and then you take both and put in the last one to find the other variable. So you have the solution for this. There are 4, 5, 6, 7 problems here that I show you how to do number 6, because the other one is just 2 equations and 2 variables by using method of eliminations. Here for number 6, so what I do is I label each equation, equation number 1, equation number 2, equation number 3. Then I take 1 and 2, equation 1 and 2, and eliminate y. See, then I have one equation with just x and z. I save this. I already have equation that has x and z, and I find another one here. So I'll put these two together. Solving this by method of elimination give me z and x. Then you take these two and substitute in one of these 3 equations. It's easier to use the first one. That would give you the last variables. Okay. The next section is 6.4. In this section, it shows you how you could take the fractions and break it into sum, into partial fractions. And it shows you different equation to use. It's like when you do the long division. In the long division, you come up with a remainder at the end and a part, or the divisor. So to understand this formula, you go and refer to each example or the problems, and you understand better how you break fractions. For instance, in this one, write the partial fractions. Okay, what I do is first I try to factor this into 2 parentheses. All right, so this one, it's now you have, this one is very similar to this example. So what you do is you just break this into 2 fractions. They both have this kind of denominators. Then you combine these 2. I want to show you this one, this part. Now I want to work on these equations. The common denominator is x minus 3 times x plus 2. Then a times x plus 2 plus b times x minus 3. And on this side, I have x plus 7 over x2 minus x minus 6, or just x minus 3 times x plus 2. Now, when you distribute a, you have ax plus 2a plus bx minus 3b. See, the denominators can cancel. You don't need that anymore. So this is what you have on each side. And then these two, you factor x out. So is a plus b is equal to x plus 2a minus 3b. And here you have like 1x plus 7. Since these two sides are equal, coefficient of x here is a plus b, and here is 1. So a plus b has to be equal to 1. Remainder, or a constant here is 7, constant here is here. 2a minus 3b also needs to be equal to 7. So now you see you have an equation that has two variables. And you solve this to find a and b. That's what they have here. When you find a and b, then you put it back here into these equations, and that show you how to take these fractions into partial fractions, break it into two fractions. So here, they show you how to break a fraction. This is the case that the highest power of x is greater than highest power of denominator. So you could use the long division for it. When you use the long division, then you end up having this one is equal to that. Okay, so this type of equations, you have x, which is there here, plus divisor and the remainder. Okay, let's think of this. Let's say you want to take 7 and divide by 2. Is 3, 6 is 0.5, right? So how do you write that? You just say 7 divided by 2. How do I check the divisions? Is 2 times 3 plus 1 over 2, okay? So your divisor is always at the denominator, okay? So this one, which is your divisor, has to be at the denominator. 1, I'm sorry, this is 1. 1, which is the remainder, it would be at the top. Remainder here is this, right? That should be at the top. So if you follow this, then you understand how we came up with this one. So here, x4 plus 2x3 plus 6x2 plus 20x plus 6 divided by x3 plus 2x2 plus x. I know you cannot read it very well, but this is, I'm trying to put that one here, is equal to this. Divisor plus remainder divided by that. Exactly like here. 7 divided by 2 is equal, divisor multiplied by that plus remainder over the divisor. Anyway, so now this 5x2 plus 20x plus 6, which is the remainder. Now we want to take this and break it into 3 fractions. Why do we write it like that? Because this is this case. Okay, so here the power at the top is 2, at the bottom is 3. So in that case, you break it into 3 fractions, x plus 1 to power of 2. And then you take a common denominator. It's just a long way to do it, but now you understand that when you simplify this, you find your x2, you factor it, then very similar to problems I did before, but as I said, this is a longer solution. Then you like, what is the value of a is equal to what from this side is equal to what from that side. This is a case that the power of x at the top is less than power of x at the 3. And I ask you to look for homework number 10, which is very similar to this. So here, x3 plus 4x, we write it as x times x2 plus 4, okay? And then you break it into, now in these situations, then you just do not put b over that, bx plus c over that one. Then, this is in case, if the numerator, the power of x at the numerator is less than the denominator, in that case, you just put bx plus c is what they have here. And then you just cross multiply again. A times this plus x times that. Now x2, what's the coefficient of x2? A plus b, what's the coefficient of x2? 3. So a plus b is equal to 3. Cx plus 4a is equal to that. Now cx, and here is 4x. Coefficient of x is 4, coefficient of x is c. So c is equal to 4. And then the last one, 4a is equal to 4a, find that equation. So what you need to understand is the part that it's when you have this coefficient, when you have the power of x at the top is less than power of x at the bottom, then the second equation has bx. You just do not write b. Okay. And now this is very similar to homework number 10. This is very similar to that, and then I'll ask you to look at the homework number 10 here. Like this one. See, what is the power of x at the top is 3. What's the power of x at the bottom? x2 to power of 2 is x4. So you have x4 here, you have x3 here, right? So in that case, again, you break it from the load, x plus 2, parenthesis 1, x plus 2 equals 2, and so on. Very similar. The power of x is 1, power of x is 4. Okay. So here they are saying that when you break it, which one of these is the correct answer? We factor it here first. X2 minus 8x is this, then you break it into this. So you see the difference here? You have x times x minus, none of these two x has power, both have power of 1, is not more than that. In that case, you could break it into these two. Like this one, power of x is 1, power of x is 1, then multiply. But these two are multiplying, but if power of x is not 1, it's more than 1, is like 2, then you got to put what? Bx plus c here. So the difference between these problems and this problem is this one, both factors that you multiply both have power of x is 1, so you're allowed to break it like that. But here, both factors that you're multiplying, one has a power of 2. In that case, if it has a power of 2, and since it's less than this, because this is 1, you're always having bx plus c. Okay. This one, when you factor, is x2, x minus 5. Okay. This x2 is a over x plus b over x2. And the third one is c over x minus 5. Same thing here. If it's power of 3, which is greater than that, you start with x minus 5 to power of 1, x minus 5 to power of 2, x minus 5 to power of 3, so on here. All right, so I think you have this solution. I put the solution for all these. Some of them are big ones, like this one. See, all x's have power of 1, so you just break it. There is no x at the top. The one that has x power of 2 here, then you got to put bx plus c at the top. So basically, what you have here, the denominator, the power must always be 1 less than that. Okay? If this is x2, you must have x1 here. If it's x1, you don't have to put x0 here because x0 is 1. So power of, if you have power is 2, they should have 1. If you have 3, you should have x2 here and so on. Okay, but we don't have that case. So that's one of the main difference between these problems here. See that this one, none of them has power. They're all 1. See, 1. Like in this example here, power of x is 1. So this should be 2. Here. One, two, 1, 2, and so on. Okay. So that would be end of this section 6.4.